Okay, so welcome everyone. This is the Quant University guest lecture series. We have been hosting these lectures for the past few months. And as many of you know, we have been going through the evolution of how we have been thinking about AI projects. So I actually used AI to create this because we've been having so many discussions on prompting and praying. So I kind of, thought of the way companies go through their journey in four phases. It's initially the prompt and play, which everybody, when I kind of, go in and talk about robust architectures and stuff like that, we usually have someone in the room saying, we hired an intern and we wrote some prompts and it's so cool. We don't need to do much. Mostly it's in a playground state, right? And sometimes the reality hits in when you don't really understand the tokenomics and start kind of sending out really huge context windows, and then think about like, why are we charged so much for a single query, and why is this code taking so much money to generate? And it's usually the realization that life is not free. And then the reality hits with respect to prompting and praying, which Agus is very familiar with, and we've been discussing this for the past many weeks. Especially with Agentic AI, we are thinking, well, we have everything structured. We have the evals, we have, the RAG setup, we have all the engineering taken care of. But then the reality hits, like, how are we seeing these results come out? Like, why are we seeing the results the way we see? And then finally, the pressure to productionize is becoming a reality, and people now think like, well, let's fix when things break, and let's see how the deployment happens. And we're seeing a lot of stories wherein things are going to production and then it's pulled back. But then we also realize, like, it's not a software deployment life cycle. It's more of a having some amount of faith and trust, and also religion comes into play. So from the playing to the praying, we're kind of seeing the whole evolution. So there is no one else who can speak about prompting and praying and shipping and praying, which Agus has been doing forever in his career. And going back to the Ford days when Ford first started building out their cars and they put it on the street. The goal was to showcase the product, not about safety. But then if we had to do mass market, we had to think about safety. And Agus saw the world coming up in 25, 30 years. So he actually joined Ford and worked in the auto sector for a while, and then realized that his place is in the financial services world, and he has done his tour of duty at Bank of America, Wells Fargo, and through his professional career, I've known him, and as a friend, I've known him for many, many years, and it's always a pleasure to bring him back. And I've known him since he started the whole PyML project, and then the Modeva, and now with his new T-shirt, Geometrics Intelligence, and kind of working on really cool aspects. We did one workshop on the development side of things, on what the first line should be thinking about in the context of building various applications. And this time we are all going to be talking about agentic testing. So I want to share one small thing before I hand over the stage to Agus. So this series we have been doing, it's a part of the Agentic AI series and the course we have been building around it. And we had a roundtable in Boston a few months back. And we have created a course, a certificate program called Generative AI in Finance for Model Risk Professionals. The second cohort is in play, and we have had model risk professionals from multiple companies take this course, and they have given us really good feedback. So what we are going to be doing is we have a self-serve option. A lot of people, as even in the audience, are from different parts of the world. So we are creating a self-serve version, which is going to be launched next week, and we'll come back to adding additional modules to this particular course. So if anybody is interested, just give me a buzz. I'm going to post the link in here. And if there's anything we can help you and your teams to upskill yourselves with both the testing side of things and the development side of things. It's a 20-hour program, and we are putting together labs. That way you can kind of experience and make sure that your teams are up to speed on what's actually happening. And there's a guided capstone, which basically takes you to end to end. I'm kind of wearing my professorial hat. I go back to teaching in fall again in September, but I've kind of made sure that the academic rigor is there. That way, you have both the content and the materials to kind of work with the things. But in addition to that, we have been fortunate to have multiple guest speakers through this course, and we have had a whole library of content available for you. And today's module will also be available as a part of the content library, as a part of the course. So if anybody's interested, connect with me and ask me any questions. But today, we are going to be focusing on how to properly pray. And we are going to make you all converts for the religion which Agus is going to start preaching. It's a new religion, but also requires a new way of thinking. But we will keep it very, very, technical, if you will. And we'll make sure that you have labs and associated content and material. Again, the same protocol. If you have any questions, put it in the Q&A window, and I'm going to ask those. And also, Agus has a few demos he would like to show, and we can make sure that we will use the next 90 minutes or so to kind of go through the material, and we will be sharing the slides and the video after the presentation so that you will be able to review it at your leisure. Okay. With that, Agus, the stage is yours.
Yeah.
Welcome back. Thank you.
Thank you, everybody. Let me share my screen. Then we can get started. Okay. Screen 2. Let me know, Sri, if you
Yeah, I can see the slides now. Yeah.
All right. Excellent. So before I start, because this is a subject that near and dear my heart, and I spent my 30-something years on testing and validation other than building, of course, right? This is, Sri mentioned my day at Ford when I designed car engine for Ford Motor Company. So a lot of things influence what I have today and talking about, and what I would like to share with you is the design of experiment approach, how to test agentic, and failure analysis, because that's something that's very, very important, and how to do this in automated comprehensive test for comprehensive testing. That manual testing will not be doable to do comprehensive testing. A couple of weeks ago, a few weeks ago, I talked about Beyond Prompt and Pray. That's for really building govern agentic system beyond just prompting, right? So that's really engineering the system and how to build a deterministic verifier that you can use to control the agentic system. That was from a few weeks ago. Today we're going to really focus. Okay, we build agentic system. We have agentic system. How should we test and validate that? And test and validate in comprehensive way, but also in very, very scalable way. So that's what we're going to do today. So it's a lot of technical depth how to do this. What I will do today, give you overview of the methodology. As I said before, design of experiments with how to basically automatically generate comprehensive testing scenario. So we'll go deep on that, how to generate a comprehensive testing scenarios that all the edge cases will be tested. Then we will do failure analysis because we do design of experiment and we have ground truth. We'll talk about how the test scenario generated from ground truth and how to build the ground truth as well. We'll touch on that a little bit. Then we can do very attribution on the failure analysis, and we can do it in automated way. So we do ground truth, generate the ground truth as geometric oracle. Those are my T-shirt here, geometric intelligence, and we'll talk about that a little bit more. Some of you that follow my Substack, I publish the intersection between geometry and machine learning every Wednesday and Saturday. Wednesday is predictive machine learning, basically. So how the geometry play a role in machine learning and foundation for supervised machine learning. That's my Wednesday. My Saturday is really more on the language model, agentic system. Which mainly we're going to talk about today, knowledge graph and how to marry it with the with generative AI. So the ground truth, we're going to learn about how the ground truth generated in an automated way, then how we create the design, generate the test scenario based on the ground truth, and then how we run it on agent to evaluate for component for things in the agent, because agents do many steps, right? It has trajectory from perceiving, getting the data, or reaching out to a system, get data, do processing, run tool, produce output, and build plan, execute tool, and then evaluate. So the whole trajectory that need to be evaluated, the component itself on the agent, the trajectory that need to be evaluated, the entire system need to be evaluated. Then we're going to test for resilience. How good is this under edge cases? So those are the topic that we're going to talk about today, and then make sure that all the experiment that we do are reproducible. So that become evidence. If you are interested in more detail, the book is Beyond Ship and Prey. I make it tongue and cheek here. There are 4 books in LeanPub. I publish it in LeanPub because it's very easy. I update the book all the time, so you can get a free download after you own the book. You get the update. So it's just convenient for me to put it there. It has 4 books in there. If you're interested in the math, what's behind it is really the first book, Knowledge Graph Embedding as Geometric Operators. That's the foundation, how to control, and we're going to use it today, the component of that. That's the math. And then Beyond Prompt and Prey is really how to build govern agent. So that's really agent building. If you're interested in, you have a problem, your rack doesn't work, then you need to go to Beyond Chunk and Pray. That's guarantee that, to have a uh, have trustworthy rack system, something that will not hallucinate. And so that's Beyond Chunk and Pray, and Beyond Ship and Pray is really about testing and validation. The software is free to use, so you can visit Knowledge AI to get a free license. You have to register, then you can self-generate your own license that you can use for pip install Knowledge and pip install Force Loop. That's from PyPy. So those are free software. Force Loop is open source, so you can see the Python code inside and all of those. So let's start with this. Why is design of experiment? uh, I don't believe in benchmark. So that's the first thing. Uh, uh, Benchmark is looking at how often the system is right. A single number give you benchmark number. All the lot of benchmark out there give you number, but one is it average all condition, it conceal where the model fail. So that's one. The second piece is benchmark are not on your real data. So we need to do it on your real case on your specific case with your data. Hang on 1 second. Let me try to move it around here. Sorry. With your data, with your case, so you test it specifically for your case. And our interest is under which condition this is going to fail and how badly when it fail. So that's really the shift of mindset from looking at benchmark, looking at number, really running design of experiment to understand really where this thing going to fail and attribution where it failed. We're going to talk about that later, and how to fix it. Right. So that's what we do. If you think about risk management, it's in risk management we're less concerned about aggregate number. We care about where the problem is, where the failures are. Okay, so that's really the coming from all of this. When I keep talking about failure and all of failure analysis, test for failure, is really coming from my background as product design engineer. Before, when I design car engine, I always think about failure, not only thinking about horsepower and torque, but also thinking about how is this will fail. And of course, spending 20 plus years in risk management make me paranoid about failure. All right, let's start with this one first. Why we don't look at aggregate accuracy? Okay, one is overall your number can be high even in your in. This is the problem with the with machine learning as well. People look at AUC, people look at KS, people look at Gini, people look at all MSE, all those performance. Those are dangerous numbers. Those are Kegel culture that I despise. We need to look at where this is going to fail. Okay, looking at the tail, because tail determine risk. We not as risk manager, we don't look at in the middle. We look at the tail. So tail is where the failure happened, the condition that we need to do. Okay, and we need to test it with ground truth. And we're going to look at this one here. Why it's not just based on annotation, but it's really how can we attribute failure. And to do attribute failure, we need to start with the ground truth. We'll go to that, the construction of ground truth a little bit. Confounding prevent attribution. So we need to do design of experiments so we can attribute clearly. It's not an ad hoc random test that we do, or it's not just, okay, let's try this problem, let's try that problem, but really do a design of experiments so that we can find really attribute where is the source of failure. The other thing that we talk about is model judge is not evidence. And this is very, very important point, because many of you use LLM as judge. Many of you provide explanation using LLM, right? Why a certain decision. So a lot of agentic system when justify putting in the part of the audit trail, part of the evidence is the output of LLM, or the output from judge, model judge, which is LLM as well. We have to remember a second stochastic model give an opinion, not proof that claim is correct. Okay, we cannot use LLM as LLM output as evidence. It has no provenance to this, the truth. So evidence need to come from your document. Evidence need to come from source of truth, not coming from LLM. So that's one thing that we are going to do. Why the testing is why I don't use LLM only. If as a judge you can use it. Use LLM is a wonderful tool to as a to look at linguistic style, writing style, but it's not for logic or from ground truth. Ground truth needs to come from your source document, source of truth, and that you can use it as evidence. Okay. The The last point is when we testing agent, we cannot just look at input and output. We need to look at the trajectory. If I have step A, I need to produce from given A, I need to conclude with D through step B, C, and then D. It has to be A, B, C, D. It cannot just give the answer, right? So we want to make sure the procedure, the step is follow appropriately. All right. The process that we're going to go through is really we're going to start from ground truth, okay, and then we're going to talk about how the ground truth is created. I think I might have slide here. If not, I'll give a jump to another things with demo. So we're going to start from the ground truth, and then from the ground truth we're going to create base question. We'll talk about that in a little bit later. The base question. From that base question is created from the ground truth. So from the ground truth, this is the answer. We're going to convert that into base question. From the base question, then we're going to do enrichment. We use language model in a design of experiment way so that we can have variation of the test scenario, variation of the query, right? So you can say, okay, I can make the query rambling or some context get buried. I can make the question become adversarial and so on and so forth. So the process is build ground truth, create base question, then enrich it so that it has a lot of will have variation. We'll talk more detail how to do that. Okay. So let's start with the ground truth construction. How do we do ground truth construction? First is, what is the ground truth? The ground truth is your current process before the agentic day, right? You have a process. Your process produce evidence, and that evidence that you have in your process will be the ground truth. If you have a document, the document is the ground truth. So this is a human created information, right? That's the ground truth. So from the document, we're going to ingest that document, convert that document into something structured, because your document may not be structured. Your credit policy, for example, is just text, right? So we need to extract it into a structure that is basically going to. I think some of you, if I'm repetitive here because I cover it in my last podcast in Prom and Pray, is extracting into triplet, into a subject, predicate, object, head, relationship, and tail, right? So every text, big text, will be converted into that. Maybe I'll give you example on that a little bit later. And create and if it's exact number, it will be exact number, store as an exact number. So you create a structured database, which in this case is a knowledge graph with exact number. So that's the first step, ingest. Once you ingest, the ingestion need to be diagnosed, right? Is there any information that get ingested is not plausible, is contradictory. So all those things can be tested automatically using some of the things that we talk about in the geometric measure. That's the cover in the book of the knowledge graph that we talk about. So we can calculate the distance, because think about this. If I have subject, predicate, object, and the whole text converted into subject, predicate, object, and connection among those subject, predicate, object, those create graph, right? The whole thing's called knowledge graph. Now, every subject or object, we call it entities, it will be converted into numerical, dense numerical number, into factor. So every point, every entity is a factor, is a point. And then relationship is an operation from factor to factor, factor A to B. The relation it has relationship. How to make relationship A and B? Well, matrix is the language is matrix, right? The language of linear algebra of two factor, it has matrix. So if I have two factor, I can connect it, the two factor with matrix. So then if in a special situation, but I'm going to hopefully I'm going to jump a little bit on the demo at the end. We'll show it to you and how then we can calculate distance. It's a matrix. Then we can calculate distance between 2 points, right? Because I have point A, point B, I can calculate distance. I can see, hey, is this something that is close or correct, or we can judge if we have multiple things synonym or something that very similar things, and they need to fall into a near region. If it's fabricated or it's not, it should not be close to that, or it's not in there, right? So the geometric side give us a way to do all this computation in terms of distance, contradiction, consistency on the path, and all of those. So that's why we put the geometry on top of this for doing diagnostic. Then we do repair. If something that the extraction after diagnostic and there's something inconsistent, you repair it, and then you train the system to do to train and to calibrate. Remember, we have to convert all those subject, predicate, object into factor, into matrix. Those basically the training process. You can train a system to do that and to calibrate, so to calibrate the decision. So that's the ground truth construction. I will give demo later to make it more real. Or maybe I should just do that if I can. Let's see, to make it less abstract. Hang on 1 second. Let me find. I here. Let me, let me do this one. Hopefully you can see it. Can you see my screen? Yeah. Okay. So this is an example, source document. And in this case, I give very simple example on the source document. It's just table, product, fee amount, and type, right? So it get parsed. From parsing the document, it say I have 40 entities. Okay, entity is subject or object. Relationship, it has relationship among those 40 entities, creating triples. Okay, 41 triples connecting all those entities. So every fact in this case, you say late payment has fee amount of $25, and NSF check, okay, has fee amount of $35. Overdraft has fee amount of $35. Overdraft and NSF check is closely related, right? So that should in the point distance should be very close. So stop payment and so on and so forth. So you convert everything into structure information. This is the extraction. Okay. Probably I'll go to the. How about if the information is unstructured, right? The one that you see here is because of table related. Then you can do extraction using regex, regular expression extraction for table is more reliable than LLM, right? So let's see if I have example on the let's see if I have example on the okay, I think I should have example that I created on, hang on 1 second. Okay, right here. So I am doing something that, okay, I'm extracting SR26-2. right? It is a document, model risk management guidance. It's all just text. So in this case, I am using language model to extract it to see the triplet. So now you can see the triplet from there. Sorry about this one. Let me close this one. So from all those, from the original SR262, you extract it, now become triplet, becomes that's the revised guideline applies to non-generative AI and all those that we constructed as triplet, right? You got extraction. That's the first step. Ingest, you diagnose any implausibility, any contradictory, you repair it, then you train and calibrate. These whole things can be done algorithmically if you use in the analytics is all just one line call. You give the PDF or you give .md or PDF. It will crunch. It will produce the knowledge graph. Let me give a little bit more less abstract on that as well. Let me go back to the example before. I'm jumping a little bit here. Yeah. Then you can see. Let's see. You can check overdraft has fee amount $35. You got the score after all those calibration. Yep, is correct. There's a zero, small number is correct, large number is correct. Overdraft has fee amount $45 incorrect, right? Wrong. Okay. So you can have that kind of scoring because you put the geometric system, you train the system, then you do calibration, then you can come up with the threshold of the scoring. So those are the thing. Then you can see the knowledge graph if you want to visually show it. I do it in 3D embedding here. The embedding can be high dimensional. In this case, I just show the 3D embedding. So and the system that is in analytics is using a hypersphere. So it's every embedding is on the surface of hyperbole on a ball. So then the connection is basically rotation from one place to the other entities. Okay, so that's mathematically what's happened, and this has become the ground truth. Okay, all the information, your document is a ground truth. Now in design of experiment, I'm going to convert this ground truth, okay, into question, into query. So that when I give that query to the agent, it will give answer, and the answer I can check it. Okay, is the answer is in this ground truth or not? So that's the entire idea to create ground truth that later we're going to do for testing. So as I said before, you saw some of the example on the calibration and then some of the measure. Okay, so this is knowledge graph as I talked about before. Knowledge graph it has entity, it has relation, and each entity relation, each triplet, it has provenance. So connect to your original document. You know exactly. Okay, this piece in the document, it got converted into this triplet, right? So you can trace it back to the source. And this is when you say this is something that you can reliably use as evidence, right? When the agent make decision, we're going to ask the question for the agent make decision. We will be checked. Hey, will be checked with the ground truth. So we'll illustrate a little bit later. Okay, so we talked about this process before. Okay, ingest, extract, diagnose, repair. Now I have graph, and then I need to retrieve the information in the graph. That is the binding process, connecting any query, any natural language, convert into query, retrieve the graph because that's the information and you get the fact, right? So once you establish the truth, you can retrieve that as your database, basically. All right. We put math on top of that so that we can do a lot of calculation, decision making on the plausibility, consistency. We can do repair. If you ask question, the system is not, the question is not in the graph, then it's abstain. You can say it's not in there, it's not in my database, it's not in the graph. All right. We talk about calibration, the calibration process. From each of the triple, we have the geometric distance, we have a out of fold and held out sample that we can use for threshold. Then the graph can say yes, admit it, yes, or abstain, it's not, or escalate, right? This is the if someone want to make it as a so that it's not human in the loop every step. So let the graph, let the geometry make decision so that human can do on look at the exception. And this is important for automated testing that we're going to use later. All right. So here is the end-to-end process that you are doing. Okay, I have source document, I create knowledge graph, from based on knowledge graph, that's the truth. Okay, knowledge graph. I train geometric memory system, something that I talked about before. And then from this knowledge graph, we can come up, create with base query. We'll go through a little bit deeper on this. And then we're going to design of experiment enrichment. And then from design of experiment enrichment, we need to have query, test scenario, query that is more in natural language. So we use LLM to paraphrase it. Okay, use LLM to paraphrase it. We run it on the system that we testing, and then we look at the failure attribution. All right, so that's the whole process. By the way, if you want to fine tune LLM, given the ground truth and given the input, you can fine tune SLM very, very easily. Okay. The hardest part on fine tuning SLM is the data. Now you can create the data very, very easily and very automated way. Okay. This is the first step. From the graph, we're going to create base query. The base query, when we asking, we can have 18 category. I put it in 5 family. The first one, a question that dealing with retrieval or recall. We want to ask question for your system to answer, right? To retrieve the information, to give you answer, to do a fact completion, to do all those steps. So those are retrieval and recall type of question. You may have query that's dealing with comparison, ranking, or aggregation. That's another type of question, the tests that you're going to create, right? The other one is about reasoning or composition. Reasoning is dealing with conditional rule. We're dealing with if-then. Dealing with multi-hop. Multi-hop is, I talk about from A to conclude D, you have to go to step B, C, and then go to D. This is typical for you, and you're dealing in banking. You have a lot of procedure. The procedure has step by step, or you have some reasoning. You do multi-hopping. People talk about chain of thought, right? Chain of thought is a quasi way to do multi-hopping. LLM is not very good at multi-hopping. That's why people invented chain of thought, so you can do step by step. But if you represent your system, your ground truth is knowledge graph, you know exactly how to hop. You know from A go to B, B to C, C to D. So it's very, very robust multi-hopping. And this is important if you want to have system that is capable to do to execute procedure in the right sequence, or to do reasoning, because you go step A, B, C to do reasoning instead of chain of thought. And you may want to ask about consistency and integrity, and so that's another type of question. And then behavioral type of question, or operational, when it say, okay, complying with policy and something. Okay, so you can come up with all this base question. Okay, this base question is connected to every things in the, so you convert it from ground truth that you have, your knowledge graph, into base question. and that it has we talk about the math. It has all the math associated with this. Now we have the base question. Okay, this base question, we don't use LLM, right? This is just from here into standard query. Okay, standard query with this 18 category or whatever category that you want to choose among this 18, or you can add your own category if you want to. From that, now we're going to enrich it, because query can be clear, can be ambiguous, can be short, can be long, context as well. Context can be different format. It has some distraction. It can be adversarial, conflict. The user can have different persona, different role. So all kind of enrichment that you're going to do. So for each base question that you created before, you can create many different kind of variation on this. I'm putting here 40 factors of 10 group. You can apply, so you can generate all kind of variation based on this. And this is done through design of experiment, because if you do all possible combination, it's a lot, right? For example, one question is you can have 18 category, 18 times 40. Now, if you have, that's just one entity, one truth in knowledge graph. If you have 100 truth or 1,000 truth in the knowledge graph, you can see how big the explosion of all possible combination will be. That's why we use design of experiment, so that we can run for a given budget number of run, but remain comprehensive to cover the entire space. So that's the entire idea. So this is what we do. Instead of doing randomly, we do space filling, so that it's all evenly and you capture the space really well. Okay, so that's why we apply design of experiment, is so that your query generation will be comprehensive, covering all the edge cases of the factor and type and ground truth that you have. So all this step, you don't need a human intervention. All this step is algorithmic, right? And the beauty of this is you can get very comprehensive coverage of query. If you ask people to create all this query considering all of this, it will never comprehensive. People will come up with test cases in convenience instead of comprehensive test cases. So this is exactly what we want to do with the comprehensive test cases. Now we can run it. Okay, as I mentioned before, once we have the comprehensive test cases, we can run evaluation and failure attribution. Okay, and the difference in this is as well, because we have ground truth. When we run tests, we run this query, I get the result. The answer will be very simple: correct or incorrect, right? So it's just binary, because I have ground truth. I check it. The system produced, and I'm going to check it with my knowledge graph, and the answer will be correct or incorrect. So it's very, very simple, binary, yes or no. Okay, and then we can do, because yes or no, we have the design of experiment. We can run the equivalent of an analysis of variance using logistic regression to do attribution. So that's one step. The other piece that you can do with this, because you have question and answer. If you have question and answer, I can train system to do a specific things. For example, if I want to create, which one of the example that I'm going to use a little bit later, drafting response to customer complaint. right? Drafting response to customer complaint. You have example of complaint. You have example of response. We can enrich it. And from that enrichment, we can train a small language model to when given complaint, it will draft response in a very controlled way because it's really trained using data that you have. Okay, so that's another way to use this is to use it to really train supervised corpus as a testing and validator. This thing is useful too because you can use it for testing as well. All right. When we talk about testing, now we have all the tests. We also have the ground truth. Let's start the test. Now, when we start the test, one of the thing is we want to evaluate the trajectory, not only input output. Yes, we can. We do input output. In fact, but we also can test in terms of the trajectory because message coming in, LLM propose for action, then you can be checked. Okay, check for syntax, checks for policy, allowed or not allowed from policy point of view using this ground truth. Okay, and is it plausible? So should this execution allowed after this step? Can I run this step so that agent trajectory can be tested as well, and then tool call, etc. So if the agent want to do tool call, before allowed to do tool call, you check it first, right? Check, hey, in this I'm going to do tool call, access this database. I'm going to read this database. First of all, is the syntax correct? Two, because if syntax not correct and it fail, agent can still produce something, right? So you need to check. You check, hey, is it allowed from policy retrieving this data? Is it this data allowed to be used for this? That's checking policy. And plausibly, can you access? Is it correct to access this database after this step? Because you have in your business process step. If I have step A, B, and step C has to be run after step B only. So after step A, I cannot jump to step C. If you do prompt and pray, your agent may skip step B from A go to C, right? This one you things that you need to check whether that is correct or incorrect. This is testing trajectory. 4 stages in evaluation procedure. I talk about we test the component because agent calling many tool, many steps. So each step will be tested. Each tool call will be tested. So that's one. I'll give illustration on that little bit. We're going to test the system because it has multiple steps. Each step may have different weakness. So if you want to test the system, you run one test query, go through all the process, and then check the final outcome. Because if we test the component only, it's correct for this query, okay? But step B may be incorrect for that query, right? So you need to really test the component so we know how weak to understand the weakness of the component, and then test the system as well to understand how the entire system works. So that's system test. Operational tests, did it run according to the workflow, right? Step C has to be done only after step B. We cannot skip. So that's test for operational. And test for resilient, what happened when tool fails. So during testing, part of that design of experiment, we have fault injection. So to make the system fail, and we want to see when the system failed to process, how is the system going to react? Is just quietly and produce result, or it really gave a warning? Yeah, the system is failed. Human need to look at it. So testing of this 4 component using test scenario that we created before. Let me go to a few example first because I think I don't want to run out of time.
There are also a few questions, Agus. So maybe
okay,
last 10 minutes.
Let's do
we still have
the
another 20 minutes, 20, 25 minutes. Yeah, so 20, 25 minutes are still there, so you can keep
Okay.
going. Yeah.
Okay. All right. The I spoke about this in the component evaluation, again, ground truth, right? So you have question. The question, we parse it, okay? Parse the question because the query is in natural language, right? Query. And then we look at it, we retrieve the ground truth, right? From this query, we get the ground truth. So this called a binding process. Basically, we can retrieve the knowledge graph from any query. So from any query, we retrieve the knowledge graph. Is it in the knowledge graph? If it's in the knowledge graph, then yep, you retrieve it. If it's not, then you say, okay, it's not in there. This is important in the in this in for agent. If you have a high risk system, that you need to produce evidence how the decision are made, right? Because hey, the provenance is not the is not from LLM. The provenance, the evidence coming from your data. I retrieve it. This is the data, and this is the answer, because the answer is in your knowledge graph. It's very deterministic. You ask today, you ask tomorrow, you ask the next day, the answer will be the same. And so you have your decision is explainable because, hey, the decision is made from A to B to C from the knowledge graph. And you have the provenance because each step you have the source. Unlike when you say, okay, this is the LLM make decision, and why you make decision, LLM explain it. How do you trust that explanation? Here, the explanation is very clear. It's going to this step, and you have the source document. Then you do a logistic attribution, right? We can run logistic attribution. Remember, we run with the different factor. We can check which factor are significant, clarity, clear or ambiguous query. Is the model, is the agent can handle that? So you can look at the what where what situation is the agent is weak. This is applied at system level and applied at component level. I'm going to use some example to make it really more real. Okay. So the problem that I have here is a complaint classification. So we have customer email. We're going to extract the fact. We're going to search policy applicable to that complaint, right? So first is classify complaint or no complaint, okay? Or just inquiry or complaint. So you have a classifier, right? So we're going to test how correct is the system classifying complaint or not complaint, right? And remember, we have ground truth before, right? That we can create complaint or not complaint. So we're going to check the performance of complaint or not complaint. Then extracting flag from the complaint, because we're going to map it with anything that map with the policy. If it map with the policy, then we say, okay, is there something that we need to flag because of regulatory? Oh, this is dealing with UDAP, so it need to get escalated, right? So that's flag for regulatory flag, and then from there drafting the response, email response to the complaint. So this whole stack. If people do it prompt and pray, you just put prompt with some context, with all of this to do the whole step, right? If people do, I spoke about this in a couple of weeks ago. If you want to do it really govern agent, then you break it down. Each step you break it down, and each step you engineer it in more reliable way than just using LLM. For example, classifying complaint, you can throw it to LLM and ask LLM, is this complaint or not complaint? Well, LLM can do whatever they want according to the context that you have. Sometimes good, sometimes bad, you don't know. But if you want to do it something that reliable, you build or if you want to do benchmark, part of your testing, you build benchmark. Then you say, I have the design of experiment data. let me fine-tune small language model to be able to do complaint classification. So then you train it, fine-tune your language model to be able to do complaint classification. And with that, you know what is the type 1 error, the type 2 error, and you can use it as your testing benchmark to whatever system that you're going to use, right? So you can use it for testing purpose where you know exactly in what's in the what is that, and in this situation when you test it with the DOE, you also know in what situation, in what kind of query the complaint classification is incorrect, in what condition the complaint classification is incorrect. So all this DOE can be applied at every step of the process to identify which component in the process, which step in my agentic that the component is weak because it's different step given the testing will have different weakness. So one DOE apply it 5 times for each component. So that's component testing. And system testing, I run the DOE and I get correct, incorrect from this final output. Yeah. Component testing, run the DOE, correct, incorrect, and each step. System testing, one DOE, run it, and get the output. That's system testing. Trajectory testing, you run the DOE and see how the transition from states to states. So that's the trajectory DOE. And you also check, hey, I search policy, but I need to extract fact first. I cannot just say, given this, tell me what policy will match, right? So we need to know why the policy will match. We isolate certain fact first. This way, make it really, auditable if you want to do the governance agentic. So this is the process that the agent that we are testing under. So I hope that clarify what I mean by component testing, what I mean by system testing. All right. Then you can get the result. Okay. Classifier. I tested. Okay. In this system, it's actually a fine-tuned small language model running the DOE. We can say, okay, classifier accuracy is 0.9. Okay. And then I do a recall. Okay. Information recall. And on this step. Okay. Finding policy. So we can test along the way every step to have performance on the component, and then test the whole system. And part of that also we test. Remember, we test for one of the tests on the fault detection. If we inject, then we create failure. Is the failure silent? Or is the failure get identified? Your agent can say, I am failing on this, I cannot do, and escalate. All right. So all of this step can be done in a very, very automated way. You run it end to end. You don't have to do it manually because, hey, I start with my document. I apply the catalog of base and factor that we talk about, and coming up with the ground truth and all this design DOE and run and attribute so you can have the whole system end to end. That's what the force loop tool is. If you want to try it, the force loop tool is. It has all the ground truth creation, the DOE generation, run the entire thing and check. Okay, the math, all the calculation is in Knowledge. So for loop is application to build govern agent and to do automated testing and also to do GMS rack. Set the force loop. The math, the foundation of math, all the calculation is under Knowledge library. All right. So if I want to do demo a little bit on this, and then we can open it for Q&A. Okay. If we compare to what is the existing practice, people do benchmark. Now we say, no, we don't do benchmark anymore. We're going to design an experiment. We can understand completely probability of failure in what condition, attribution. So that's one key things that yeah, you want to do. LLM job as predict. We don't do LLM jobs as predict. We use calibrated geometric distance. The known false accept rate, and it's replayable. If you run it once, you run it twice, you run it 3 times, you get the same result. If you do this, all this analysis, you can just prompt it. Okay, test, you can ask, you can try with Cloud Code, for example, connect it with your system under test and ask Cloud Code to test it. It will do that too, but it's not you run it today, you run it tomorrow, you get different result, right? So what you do with this is you run it today, the test you run it tomorrow, you run it next day, you get it's reproducible. I don't do hand label answer key, right? I don't create manually the scenario of testing. Ground truth is generated from whatever the source document that you have. We created knowledge graph. It's a ground truth. We test trajectory, component system, operational resilience instead of testing just input and output. And we do the attribution and we rank them, we score them, we know exactly the model weakness. Okay, let me do this summary, then I'll just do demo. Okay, by now I hope I convince you evaluation is a design of experiment. Ground truth is generated, not annotated, right? We created ground truth from extraction and create knowledge graph. The knowledge graph is your ground truth. We do attribution of failure instead of aggregation. So let me do a few demo on this so that it will be less abstract. Let's see. Then we will open it for Q&A. All right. So I show you before. Let me go back. This is example of multi-hopping that you can do, because if let me explain multi-hopping. Multi-hopping is overdraft. You can go to here and then you go to what's next and then get escalated, right? So because it's overdraft, abuse, for example, deceptive, whatever, and then get escalation. So you can do multi-hopping. Follow the track, okay? So here is an example. Let's see. Let me get the example of the multi-hopping. See the example tracing the knowledge graph from unfair, abusive fee, UDAP, you get escalate, right? So that's an example of when when things get escalated, you know exactly it's going to the step process, the procedure, and you have the provenance on this, because you can connect it to here is the policy, and what happened is this, and this, because that's the procedure in the policy. I spoke about plausibility and distance. So you can see a overdraft 35 and 45, it will be so wrong. So you detect it, able to detect it, right? And it has logic. Exact number. This is very, very important when dealing with with financial application. A number has to be exact, right? When embedding is terrible with number, okay. Language model is not very good with number too, because it's just close enough. It doesn't understand number. It's trained to produce the next token, not trained to compute, right? So to do that, you need the exact numerical number. That's what the geometric memory system produces. Is that you can you see on the link predict, if you give the overdraft has fee amount, what amount, okay, and then you can see, okay, $35 is correct, okay, score low, $25 is incorrect. $45 is incorrect. So you can do all of this because on the knowledge on using geometric operator, which knowledge graph cannot do because knowledge graph is binary. So I show you the visualization before. That's let me do the design of experiment enrichment process. I talk about enriching from the base question. Okay, the base message. I was charged $35 and I want it removed, right? Uh, the Here is a few example, clear, canonical, and none. This is the DOE factor. I was charged, I was removed. So it stayed the same, okay? And then, okay, make it ambiguous. I'm not totally sure how to put this, but it was charged $35 fee, blah, blah, blah. So you can create all of this variation based on the design of experiment factor that you have, okay? One key important in the in building this system that is query and ground truth are correct is this. Remember that the way it get produced is from ground truth in the knowledge graph. We create queries. When we create query and you have all DOE applied, you have LLM applied, you want to make sure it doesn't drift, that the answer is still the ground truth. Yeah, so that's what happened in the software package that you have. It has internal check, the process checking to make sure that the phrasing of the question is invariance. The answer is still the ground truth, right? If the answer is not the ground truth, that question will get discarded because we don't have the ground truth. So the process from doing inverse from ground truth to final query, remember the final query, the test is that the final query paraphrase is using LLM, and your LLM can drift. If your LLM drift, you get question that's nothing to do or not. The ground truth is not retrievable anymore. Then it's not a good query, right? So that's we want to do it variation, but variation that stay with the ground truth as the answer. So that's it. I think we have 15 minutes for Q&A.
Perfect. Yeah, perfect timing, those. So we have a couple of questions. I'm going to try and see if I can sequence them. So let's take care of some of the specific questions regarding design of experiments. Anish had a question. Do you use any specific kind of design of experiment, Taguchi or CCD or any specific ones, or is it agnostic to the methodology?
Yeah. You can do anything, but I prefer to do what I call it space filling. Okay. Because you feel free to read my article. So what you need to do, because fractional factorial and all of those, it will be too big. Okay. So what you can do if you want to do fractional factorial, the problem is some of the level are 4 level, 5 level, 6 level. Okay. For example, if I do multi-hopping question, it can be 1 hop, 2 hop, 4 hop, 6 hop, 8 hops. Okay. So then your traditional factorial design is very hard to deal with, because some of the cardinality of the factor can be a lot. Yeah. For example, another example, roles. Okay. Who are the person who the user of the tool? It can have different role, different expertise. It can be many level, which standard factorial design will be hard to apply. So the way to do it is what we call it a space filling design. I wrote a textbook on this back in 2005 in my expertise here on this. You can find my book in Amazon. And anyway, I also published paper on this that you can read in SSRN. Yeah. That paper is in review with the Annal of Statistics right now. Okay, the most theoretical journal in statistics, right? So it's how to generate design that is really even, very uniform in the entire space with different cardinality for level for each factor. But you can if you want to. Okay, if your factor your cardinality are very low, okay, then you can do any factorial design, any fractional factorial design. The answer is yes. The one that I implemented in the system is based on Sobol sequence, optimized Sobol sequence, which is a quasi Monte Carlo techniques. Yeah, using Sobol sequence that's optimized for uniformity. Okay, using criteria called maximum distance. Okay, so that's the answer. Okay,
Yes.
all right.
Awesome. There are a couple of questions on knowledge graph, Gus. So I'm going to try and
Yeah.
see if I can consolidate them. So one is, how is the ontology embedded in this knowledge graph?
Yeah. Ontology is sometimes some people may get offended by me here, okay? Because I'm abusing knowledge graph. Ontology is no more than you canonize. You use the same terminology. If you see it in my example before, has something, okay? So ontology, all what you need is what? Common definition of entity, common definition of relationship. That's it. That's all what you need. And people try to make ontology as complicated science. Okay, it's not. Okay, you just need to have common vocabulary. Okay, common vocabulary on the entity definition, because U.S., USA, United States, it's all the same. Okay, so right, so overdraft fee, NSF, overdraft, NSF, and all of those they are the same. Okay, so it's really about normalization, about common term that you use. Now, this is the beauty, and the difficulty is you have ontology, you have query, people can use it, query it, whatever they want. It's not in your ontology. Okay, it's not in your vocabulary. How do you deal with it? Okay, that's exactly what we are solving here. How to bind natural language into the definition in your knowledge graph. Yeah. So that's what how to make LLM now. Understand this. So that's what's included in the system. We train small language model to write the right query. So anything, any natural language, it will process into query that you can find in knowledge graph if it's there. Yeah, if it's not there, it will not be there. So it really is okay. Sometimes people make it too scary in my view. You know, at the end of the day, what do you need? What do we need is common definition, right? Common language. So the complexity on people that try to make this one into science is okay. We're going to have a knowledge, company-wide knowledge graph. Well, that's too ambitious. We are dealing with something very specific. I am talking about deposit. Okay, I am talking about mortgage. So the definition are very the uses are very narrow. We're not talking about trying to be ambitious, creating knowledge graph for the entire corporation. If you have to create knowledge graph for the entire corporation, yes, you have to. The process of building ontology is complicated because everybody needs to speak the same language, right? But we are very narrow. The vocabulary, the language. If I'm talking about complaint, I have Reg E, I have Reg X, I have UDAP, I have all the regulatory that apply, right? And then I have my or I have my credit strategy document. So it's very specific, right? So it's I say it's less problematic in that. And then you check it with design of experiment that we talk about. Hey, can I find it? Can I find the information? Then you train your binding process tuning LLM, a small language model, to be able to bind it. Okay.
Yeah. So another question. So I mean, I think and we have discussed this in the course too, because there is a significant dependency on the upstream processes when it comes down to like model risk doing the validation. There is the
Hey,
data part and the whole thing. So
yeah,
Walter had a question associated with, there is the testing and the resiliency tests and all the other tests that
yeah,
we done. So how much of it is dependent on the knowledge graph in the sense
yeah.
that, can we think about all these like, multi-hopping capabilities, but can we get away without the knowledge graph and just focus on the testing piece was a question.
Now, the question is for the testing piece, you need to create ground truth.
Mm-hmm.
Yeah. Uh, how do you have the ground truth? You don't have to have knowledge graph if you have ground truth, right? So we do have knowledge graph because we need to create ground truth. If you have ground truth that you manually curate it, okay, you manually create it. But how many can you do with that? Right? So yes, if you have example, I'm not going to create knowledge graph for ground truth, but I can use this, I can enrich it. Let's say I have 20 question and answer, 20 example. I can create 1,000 variation of this or 10,000 variation of this by applying DOE enrichment. So I can have many, many different things, but I know the invariance. The invariance is what? The label, the target. Complaint or no complaint, right? I have 20 example of customer complaint, 20 example of non-complaint. I can create variation of that using DOE, but I have the label already. Yes, and something like that, you apply it like that, right? So you don't need knowledge graph or something like that.
And how do you
Oh,
check about the plausibility and the appropriateness of the generated, examples?
exactly.
Yeah.
Exactly, right? That's what the process in the knowledge graph, we say, okay, if I generate it, can I find it back?
Mm-hmm.
Yeah.
Yeah.
So you check first before you use, can I find it back? If I
Mm-hmm.
can find it back, that's a good test. Yeah.
Yeah.
I
Yeah.
can find it back. That's the process that is in there. Hey, by the way, people question, how do you use this, integrate this package? It's Python library. You can call it. You can put it in your code agent. Okay. You can upload it to your code agent. Okay. And create skill to make sure your code agent using this library. Okay. And then your code agent skill will make sure it will check the available API first. So it's very, very simple to use because it's Python package. You can see it. So how you integrate it? Just it's Python package, and create a little skill.md to say before you build anything, check this library, all right? And use the library, existing library. So that's the easy way to do. Okay, but it's Python package. For Sloop is open source. It's all in there. You can see the code line by line. Okay.
Perfect. So a couple of questions on knowledge on the ground truth itself. How do you, and I'll kind of combine both these questions. How do you handle scenarios wherein the ground truth itself is dynamic? Example, news articles, news is evolving.
Oh yeah,
And
yeah,
then the other question is, what if it's hard to get, as in like a negotiation agent? I don't know the full
yeah,
context, but
yeah.
yeah.
So dynamic, the package letting you do dynamics. Yeah, the package is okay. This is the starting point. You train it. You have a train system, and then because I use it for tracing agent, for the all the interaction of the agent do, I store it as knowledge graph, the whole interaction. So it's dynamics. Yeah. So you can grow it in this, because when it grow, it a new thing's coming, it will be checked. Is it contradictory? If it's contradictory, it will flag with the existing knowledge. Yeah. So this is prevent any drift in your memory. So basically, when you use knowledge graph like this is why I name it GMS, Geometric Memory System. This is a structured memory which you can grow, but then when grow, it will check. Is it contradictory with existing knowledge?
Mm.
Then you can delete, you can update. When you have a new things coming in, it's not retraining the entire system. I only retrain what's get added. The new thing, new entity get added. I need to find a location, right? A point in the high dimensional space. And then I need to train the relationship with existing entities. So it's growing. It's growing. You can grow it. Yeah.
Mhm.
So in fact, I do use it for growing memory.
Mhm.
Okay.
And
So go on.
I think um, the notion of ground truth, when it comes down to, I think you mentioned, like, kind of scoping it versus building a knowledge graph for the whole company-wide
Yeah,
database,
yeah.
right? So do you see
Because
any
your
kind
agent
of,
is always very narrow application, right? Your
right?
agent is narrow application. Your agent represent existing process. Existing process as example of output. Existing process has procedure. In banks in particular, you have
Hmm.
procedure, you have policy, you have guidelines, right? All the standard that you have, that is your ground truth.
Yeah. And how do
Yeah,
you keep updating it? For example, SR 11.7 was kind of the ground truth for
yeah,
most policies, and now you got to
yeah.
remove it and
It's it's
replace
it's
it with
it's it's
26.2.
it's the same thing like how you maintain your database,
Okay.
right? It's the same thing. Hey, is it still useful, or we wanna build it over? You want to add,
Hmm.
or you want to replace?
Yeah.
Every time you add or every time you replace, is the system is trained and calibrated, right? So that it can do contradiction and plausibility, and holonomy check is basically checking that the path is consistent.
Hmm. So I think I'm gonna try and avoid one question, but connecting question I would love to ask. So where do you see, you know, I mean, there is a huge process involved, right? Like, do you see model risk owning this entire pipeline, or is it more of a company-wide decision to incorporate, like, uh, even the developers need to kind of adhere to this creation process, updating
Well,
process,
it
validation?
depend it depend where you are, right? If
Hmm.
you do testing that I show you before, this is only for testing, for model validation to use. You can set up automated validation,
Hmm.
right? And you set up automated validation, then MRM own it, because as you use it for MRM for validation. You can do it validation really fast now because of this. Yeah, identification model weakness and all those things is automatic, right? So if that is the use is an MRM. If I am a developer, what do I do? It depends in what application. Then I say, am I going to use it as verifier? I can use it as verification, right?
Hmm.
To make sure that the answer is always correct. The answer is grounded, right? Grounded to the policy, grounded to the process, grounded the procedure that I have. Okay, so that I use it as verifier, right?
Hmm.
uh, if I'm developer and I need to fine tune for small language model, I use it to data generation
Hmm.
for fine tuning model,
Hmm.
right? So it really depends from application to application. And sometimes I built one system for one of the large bank for very high risk application on credit strategy. So no
Hmm.
hallucination needed. We cannot do that. Okay. So what do we do? So the process is LLM propose, but it's only propose. the ground truth here, the GMS, is going to verify whether allowed or not allowed. Okay, so that's one. In the other part, the system that very deterministic, we're not allowing LLM even propose. LLM is only input and output in natural language. It's UI. Everything else, the step, the orchestration, and things using your memory system, that's become super deterministic because LLM is only input and output. Anything in between is LLM propose, my verifier will do approval. All the way to the left, prom and pray. Okay, so you have from prom and pray to deterministic system, and where you want to insert it to have safety. So that if you are in the front line on the development, if I'm on the model validation, my goal is I'm interested in adversarial tests and all those things. So I'm going to do this for adversarial tests, automated testing.
I think we have time for one more question, Agus. I think Pradeep was asking, you are not a big fan of benchmarking you mentioned before. Any specific reasons?
Yeah, because benchmark give you single number. Single number is very dangerous in model risk management and in development. When I design engine, I don't test my engine in nice afternoon in lab. I tested in very cold day in Minnesota. Yeah, I tested in high altitude in Colorado. I tested in hot summer humid day in Miami. So benchmark means nothing for me. I need to test to identify weakness.
Yeah, that's true. Yeah, I remember my testing days too. For I didn't get the pleasure of designing cars, but I was designing hydraulic excavators, which was much more fun because I could like throw mud here and there and not have to worry about the road. The road was like we could dig
So
as deep a hole.
I never fans of benchmark.
Yeah,
the number is super dangerous. So when people do benchmark on this today on the foundational tabular data and all those things, for me, it's complete bullshit. At the end of the day, I test it for specific application and I want to know where it failed.
Yeah. So I'm actually building another course for coding agent validation, and I'll actually have an offline discussion with you because I think I have some more specific questions. Maybe it's not in the scope of this session, but maybe in another session on how we think about, not the ground truth becoming the code and representing the existing code base as a knowledge graph, and then using that for coding and, building
there is an
out
open source that did that already.
the
Create knowledge
Graphify, a
graph.
bunch of
Now,
other,
what you need is put on top of that, on the knowledge graph, put the GMS system so that the GMS, you can do decision making instead of just database. Knowledge graph is database.
Right.
Now we want to make it alive. How to make it alive? Put algebra, put matrix, put operators.
Yeah. So I'm excited about all the direction you're going, Agus. I mean, it's a fascinating area. I think we need more discussions. I think unfortunately we are running out of time. We ran out of time actually, but we should have a couple more sessions as you start building out your library of LeanPub books, and just kind of have one session at a time. But I know you're kind of
the book, by the way, every chapter has Jupyter Notebook, has code and Jupyter Notebook. So when you look at the book, you got the notebook that you can look at the in the GitHub, and you have the code as you install it basically, pip install, and you have the notebook, and chapter by chapter has notebook, so you can go through step by step.
Yeah, and for people in the audience, this video, which is being recorded alongside with the slides and all the links Agus shared, will be available on QSkillBridge. So when you get your email tomorrow, you have everything in one place. So you can reach out to Agus or kind of go through the materials and I think it requires
Sri,
time
you're
to
going
just make
to
sure that you.
distribute the presentation, right? You have all the link and all of
Yes, I
those
am.
in the
Yeah. So that
presentation.
the presentation, all the links you shared, and also the video which is being recorded. So we'll put everything in one place so that people have
Yeah.
access to it tomorrow. So it'll be in the
All
email which
right.
goes out tomorrow. Yeah.
This is thank you everybody.
Cool.
This is the thing that I do now post my retirement. I don't have to do management entertainment anymore, right? So I spend my time indulge myself on the
Well,
technical stuff.
in some way, Agus, you're unshackled to do the things you want, but you're shackling yourselves with the things you really want to be in. So, it's kind of a labor of love, but also in some ways you're kind of choosing freedom and going back to, the design of experiments, and you're kind of imposing your own constraints and creating your own degrees of freedom. So I hope you have much more degrees of freedom and find your place in the hyperplane you really want to be in.
Hypersphere.
Hypersphere,
I'm
hypersphere.
working on Lie algebra. Okay, geometric
Okay.
algebra, Lie algebra, hypersphere.
Absolutely, absolutely. Yeah, in the n-dimensional sphere. But let's keep the discussion going. This was absolutely fun, and people in the audience, we're going to continue hosting, these kinds of sessions over time, and we want to build this community of practitioners, bringing in real-world experience, making this practical, and also grow as a profession. I mean, every time I speak to my consulting clients or people in the audience when we have our classes, it's always the question of like, how are we going to upskill ourselves? And I think that's
Yeah.
that's where the model risk profession is evolving, the developer profession is evolving, and the technologies themselves are evolving. So I think you got to be all eyes and ears with all the things which are happening so that you can contextualize and bring it into your
Yeah. Yeah.
workplace. And
Happy
also
to
with
keep learning on this. I'm learning myself, but that's what make
exactly
it
right. I mean, like
exciting and
I'm learning more than actually delivering, because I think that's the fun of being in this world. There's so much happening in the learning sphere. So I think we should continue the discussion offline. We will adjourn for today's session. Agus, thank you again for this wonderful session and making time for us.
Thank
You're
you,
welcome to
everybody.
come back again and again. I mean, and anytime you have something new, please do share it with us so we can kind of use this as a medium to impart it to the wider audience in the world. Okay. Thanks again,
Excellent.
and all the participants who participated in today's session. If you have any questions, feel free to reach out to us, and we will continue the discussion online. And we'll see you in the next session. Thanks again.
All right. Thank you so much.
Okay.